Something I've been meaning to cover on this channel for a while now is the NVIDIA Jetson board, and here is the perfect opportunity. NVIDIA have just re-released their Jetson Orin Nano Developer Kit with more power and a lower price, and they've sent me one to try out. I'll give a quick overview of the Jetson platform for those who aren't familiar, what it is and why you might want one, and then we'll take a look at how it goes in some robotics applications, including integrating with ROS. As always, you can use the chapter markers to skip around. NVIDIA's Jetson products are a whole family of embedded computing boards. Each one contains a version of NVIDIA's Tegra system on a chip, which includes the CPU and GPU, and then it couples it with some RAM, storage, and everything else that's needed to turn it into a fully functioning mini computer. But this little computer doesn't have any of the ports or anything you'd expect to see. In fact, most of them just look like a stick of RAM. The idea is that as you develop a product, maybe the next automated lawnmower, rather than having to individually select and test all these components yourself, you can buy this little board that you know is going to work, and then you add whatever application-specific circuitry you have around that. So if you need USB ports or video output, you can add those to your circuit. Other board designers have used similar concepts, like the Raspberry Pi compute module, but of course the Jetson's specialty is that it has those CUDA cores that are great for doing parallel processing applications, like image processing or large language models. During development though, you don't know what you need yet, and that's where the developer kit comes in. This is a Jetson board that's been stuck onto a bigger carrier board that exposes all the usual interfaces, so Ethernet, USB, and so on. It's got a nice heatsink and a fan for the processor. It's even got header pins that match the layout of the Raspberry Pi, so it makes that nice and familiar. Once you've prototyped your product with the developer kit, you can then go and design your custom PCB around the Jetson board itself, go and order hundreds of thousands of those, and ship them off to your customers. Or maybe you're a student or a hobbyist or just building a one-off, in which case this makes a great all-in-one platform for any kind of project. Now here today we have the Jetson Orin Nano Super Developer Kit. So this is a developer kit for the Orin Nano series of boards. Now don't get mixed up, this is not for the Orin NX or AGX boards, it's not for the Jetson Nano boards, which are other products in a fairly confusingly named lineup. But the Orin Nano boards sit in a pretty comfortable middle ground. They're less powerful than the Orin NX or AGX series, but more powerful than the Xavier TX2 or Jetson Nano boards, while still maintaining a fairly modest power requirement. Now you might be wondering, what makes this Super Developer Kit any different from the regular developer kit? And the answer is nothing. It's the exact same product. All that's happened is NVIDIA has updated the code to allow it to squeeze a bit more juice out of the same chip, and they've reduced the price from $500 US to $250 US. If you have an existing Orin Nano, then you'll be able to update it to get the new performance, and as far as the price is concerned, you can just choose to be happy that the new lower price is going to lower the barrier to entry overall, and maybe it means you'll be able to get more boards for other people in your team or something like that. I will say that it now looks like the price for the developer kit is lower than the price for just the Orin Nano board itself, which is a little bit strange. Maybe they're going to drop the price of the board at some point, or maybe instead they're trying to bring the developer kit price down really low to try and bring more developers into the ecosystem and then limit sales of that to development quantities. And if you're wanting to buy hundreds of boards, then you're probably going through some distributor anyway. That's enough talk, let's see it in action. NVIDIA gave me some quick tutorials to run through, which were focused on locally served LLMs, since those are pretty trendy at the moment. It was easy to get Ollama installed with a web interface, and it wasn't long before I was up and running, asking it questions. Now, it was a little bit slow sometimes, and the jokes weren't that funny, but I probably can't blame that one on the hardware. I tried asking it some questions about the Jetson, and the base knowledge wasn't quite deep enough to get what I wanted, but I was able to feed it the PDF of the carrier board specs, add that to its knowledge base, get it to recompute, and then it could answer the questions perfectly. LLMs are definitely making their way into robotics, but I want to focus on the more typical application of this hardware: perception. The main reason you'd want to build your robot around a board like the Jetson is to take advantage of its hardware for processing sensor data from a camera or a LiDAR at a high rate. So that could be detecting people, or finding the pose of an object, or localization, and being able to do this at a high rate with minimal impact on the CPU. NVIDIA has their own robot software ecosystem called Isaac. Isaac builds on top of ROS, adding a bunch of packages, models, simulations, and so on that allow for CUDA-accelerated robotics computing. NVIDIA provides helper scripts and that sort of thing that make it easy to get started running pre-trained models inside a Docker container. If you have a look through the documentation, you'll notice that in addition to strongly recommending you use Docker, it's required that you use an NVMe drive for storage instead of the microSD card. You can see there are two M.2 sockets on the bottom of the carrier board here. I didn't have a spare NVMe drive, so I did everything on the microSD, but I could tell it was really struggling, so I'll probably install a drive in here at some point. And I didn't have too much trouble hooking up a USB webcam and running the Isaac ROS April tag demo. If you don't know, April tags are a popular fiducial marker that you can use for tracking in robotics. I'm actually pretty keen to do a deep dive on these at some point, so let me know if you'd be interested in that. I'd hoped the April tag benchmark might be useful too, but I think my numbers were getting bottlenecked by the log playback off the microSD card. In the first 3 stages of the test, which seemed okay, I averaged 52 FPS on the old 15-watt mode and 70 FPS on the new higher power mode, an improvement of just over 1.3 times. To get some more clarity, I tried the localization benchmark, and it spits out a whole bunch of numbers, but 3 that I found helpful are that the benchmark took 185 seconds to run in the new mode compared to 240 on the old mode. The median processing time for the localization function was 156 milliseconds compared to 232 milliseconds, resulting in a mean FPS of 6.4 compared to 4.4. Overall in this benchmark, the new mode is 1.3 to 1.5 times faster than the old one. NVIDIA claims a 1.7 times improvement in AI performance in raw operations per second, so that's probably feasible on the right sort of problem. For the next few demos, I ran into some dependency issues around PyTorch and Torch Vision and having CUDA enabled. I'm not sure what the right way around these was, but I eventually managed to get it to work one way and was able to run the mobile segment anything demo. So you can see here it picks out the people, and the dope pose estimation demo, where it picks out this source bottle. Unfortunately, when I tried to run the benchmarks for these libraries, which I think would have been really useful, I ran into some tensor errors, which I just didn't have time to dive into and debug. I also found that with the new power mode, I frequently ran into this overcurrent warning. I'm not sure exactly what triggers it, what the implications are, what causes it to revert back to normal, but it's just something to be aware of if you're wanting to take advantage of this extra power. You don't want it throttling on you all of a sudden. Something else I'll add is that the structure of the Isaac ROS demos and libraries can be pretty overwhelming. There's plenty of quick start documentation and tutorials, but it's hard to know exactly where to look and which commands you should be running. I'm keen to explore this further for myself, so if this is something you're interested in, please let me know down in the comments, and in the future I might do some more content around this to help you get started with how you can use a Jetson with ROS and Isaac and CUDA and all of this stuff to make cooler robots. Overall, I think the best thing to come out of this new announcement by NVIDIA is the price drop. There are plenty of really interesting things going on in the parallel computing space, and that's fine for someone with a 4090 in a tower, but it's great that we can lower the barrier to entry for some of this embedded hardware. I'm hoping this results in more people developing new and better robotics algorithms that we can all take advantage of. The new power mode is great too, especially in a development or an exploratory context, but I want to do some pretty thorough testing before I went about using that inside a production environment. So whether you're a student or a hobbyist or a developer, if you've been wanting to explore the power of AI and CUDA in a robotics context, this is the perfect time to jump in. Thanks to all the patrons who support the channel. I'm actually going to be reworking the Patreon a little bit over the next month. There'll be more announcements on that later, But if you like what you see here and you want to see more of it, please consider joining over at Patreon to support this work. Otherwise, I'll see you next time.